Okay, our last example is going to highlight how this question can take a long time. So I'm going to do some of it for you. I'd encourage you to, you know, maybe look at this. You could copy it down or print off the note from Noodle and try this on your own. But I'm going to rush through this one and let you see how you can just double check your answer with the one that you'll see on the screen. So in this example here, how do these questions get harder? Well, of course, I give you the equation of the plane, but not in scalar form. Since it's not in scalar form, you're going to have to do a whole lot of work just to put it in scalar form, just so you can even start the question. Now, as you're going along, you'll be able to maybe eliminate some of the possibilities, check for parallel and that sort of stuff. But you're going to look at this question and see, okay, I've got two planes, but they're not in scalar form. So instead of going through it very quickly or go through every step-by-step with you, I'm going to go through this quickly. And if you want to check this after or copy it down, then you can have the supply teacher come back to this screen. But remember, here I've got plane 1 given x, y, z, and then plane 2 giving x, y, z, this time in variables u and v. Remember that to get it in scalar form, we need to get the two direction vectors from each one to their cross product to get the normal. So from the first one, you'll see the direction vectors are 1, -1, and 0. And you'll see that written right here. So it's 1, -1, and then there's no r, so you see it's 1, 1, 0. And the other direction vector is -2, -1, and 1. So there's that direction vector right there. Copy down twice, cross product, and you can check later that the normal then is 1, -1, 1. Repeat the same step over here, except our different direction vectors, -1, 1, and 3. So there's -1, 1, and 3. And the ones on the V would be -1, -3, and 2. -1, -3, and 2. Write them down twice. Cross product and check your math that the normal is 11, -1, and 4. So at this stage, we had to compare normals anyways. So we find out that these normals are not scalar multiples of each other. And so we can see that they're not parallel. Next, we got to figure out what the scalar equation is. So remember, we can write each of them, since we have the normals, we can write each of them using these normals. So you see the 1 becomes 1x, the -1 becomes -1y, and the 1 becomes z plus something equals d. And then for the other equation, we've got 11x, -1y, and 4z plus something equals 0. How do we get that something? Remember, we plug in the points. And right at the top, you'll see that the point was 1, 0, -3. Remember, that comes from here. 1, there's nothing here, so 0, and then -3. And take that and plug it in here. The second point over here was 2, -1, 0. Right from the question, plug that in. Once you plug those in, you'll get that d equals 2 in the first equation, and therefore it is x minus y plus z plus 2 equals 0. And then the second one was d equals -23. So you plug that in and you get 11x minus y plus 4z minus 23 equals 0. And now we can begin the question. Okay, and it starts to look just like the ones that we had just done. So you can tell how this question is not any harder, but it's definitely longer. And we now go off and solve it. So at this stage, what I'd like you to do is pause the video. And I'm going to ask you to either do this on your own, or maybe you and the teacher can go back and follow the steps that we did in example 1 to try and eliminate in this case. Remember that the steps are, we're going to eliminate for x, eliminate y, and let z equal k. So pause the video, and either as a class or individually, I'd like you to eliminate x, eliminate y, let z equal k, and come up with an x equals, a y equals, and a z equals k for this line. And then we'll come back and check the solution in a moment. Okay, so hopefully you've had a chance to solve it, and now this is just a chance for you to check and see if you've done the math correctly. So I'm going to do it relatively quickly. To eliminate x, I need to multiply 1 times 11. That'll give me 11x minus 11y plus 11z plus 22 equals 0. I'll call that equation 3. I don't need to do anything to equation 2 because it's already got an 11. But I will renumber it number 4. And then I'll subtract those two, and that should eliminate my x. Minus 11 minus 1 is minus 10y. 11 minus 4 is 7z. And then 22 minus 23 is like plus 23, so plus 45. 0 minus 0, and we get this. Solve for y. Divide everything by negative 10. Actually, I'll do this. 10y equals 45 plus 7z. So that's dividing everything by negative 1 first. And then putting y equals 45 plus 7z all over 10. I'll come back to that in a second. Okay, so now I've isolated for y by eliminating x. I'm now going to eliminate y in the second part. So this will be a lot easier because I can just subtract them right away. So 1 minus 2. So that'll be 1 minus 11x is minus 10x. Negative y minus minus y eliminates. And 1 minus 4 is negative 3z. And 2 minus minus 23 is 25. 0 minus 0 is that. Isolate for x. Sorry, negative 10x equals negative 25 plus 3z. Oops. I didn't mean to put k in right yet. So that should be a 7r, 7z. And over here, this should be a 3z. Divide everything by negative 1. And then divide by 10. And I've got my x. So, if I put all these together, I'll get an answer like this. X equals, and I'm going to divide each term by 10. So it'll be 25 over 10 minus 3z over 10. The y, again, divide each of them by 10, so it'll be 45 over 10 plus 7z over 10. And the final one is z equals k, so I should have written these with k's. Now, technically that's our answer, but I don't like the fact that it's got all sorts of fractions in it. So the cool little thing I can do, the little adjustment I can do at this stage is instead of letting z equal k, I'm going to let z equal 10K. Remember, I can let it be whatever I want. So I'm going to be a little bit more creative and make it 10K. The reason I might do that is because if I replace that Z with 10K, this becomes a 10K instead. And then what of course disappears? That, and I'm left with just 7K. Same thing up here. If this was a 10K, then this and this would disappear, and I'd just be left with a 3K. Now, you can't do anything about the fractions before that, so they'll have to stay the same. You can reduce it. 25 divided by 10, divide both the top and the bottom by 5, so that would be 5 over 2 minus 3K. And then y equals, divide the top and the bottom by 5, so it'd be 9 over 2 plus 7K. And there is your final answer. We're saying that that's in simplified form. So it's just like fractions, you know, when you answer fractions, we don't like them, we like them to be reduced. So it's the same idea here. If you end up with fractions in your solving, change your Z value so that the denominators will cancel, and at least it looks a little bit nicer. Okay, so now what I'd like you to do is work on page 223. Numbers 3 to 8. Within those ones, the best ones is numbers 6 and 7. Good luck, and we'll see you tomorrow.